This podcast is called Zeros of Polynomial Functions. Might better be called Rational Zeros because we've been dealing with zeros of polynomial functions already. These are fractional zeros, zeros that aren't so easy as whole numbers. Consider, for example, the function f of x equals 2x squared minus 13x plus 15. If I want to find the zeros of that function, then I want f of x to be, I want to find values of x where f of x is 0. So I just come over here and I set f of x equals 0. If I factor that out, I get 2x minus 3 times x minus 5 is 0. And to check and make sure that's the right factoring, I'll do the first term, 2x squared. Negative 3 times negative 5 is plus 15, and negative 3x minus 10x is negative 13x. So those are the two factors, and that leads me to the solutions, x equals 3 halves and x equals 5. Now over here, I've parenthetically said 5 is the same as 5 over 1, because I want to make a point. If you look at the numerators in my two solutions, 3 and 5, they are both factors of this number 15. And if you look at my denominators, 2 and 1, they are both factors of the first coefficient, 2. So I had my numerators were factors of the last coefficient, my denominators were factors of the first. And you can kind of see how that happens when you figure out this solution right here. So I've written that up in kind of a rational zeros property here. I've said if the polynomial function f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1. So this n could be anything. You know, if it's fifth order, it would be a sub 5 x to the 5, a sub 4 x to the 4, etc. Plus all the way down to your constant term, a naught. If this polynomial function has zeros that are fractions, which we call rational zeros, the numerators of those fractions will be factors of a0, which is the last coefficient, and the denominators will be factors of a sub n, which was the first coefficient. Now to see how to use that property, I've given you here example 1, and it says find all possible rational again just means fractional, rational zeros of f of x equals 4x to the 4th minus x cubed plus 5x squared, etc. Well, my zeros would be x is equal to, now we're not sure whether they'll be positive or negative, so we put down positive or negative. Then we write down for my numerators all of the factors of 6. So I'd write 1 because 1 times 6 is 6, 2 because 2 times 3 is 6, 3 because 3 times 2 is 6, and 6 because 6 times 1 is 6. And the denominators will be factors of this first coefficient, so I'll write 1, 2, and 4 for my possible denominators. Now, what all numbers would those be? Well, if I pick 1 for my first denominator, this is going to be positive or negative, 1 because 1 over 1 is 1, 2 because 2 over 1 is 2, etc., 3, 6. Then if I go to my second denominator 2, 1 over 2 would be 1 half. 2 over 2 would be 1, but that's already in the list, so I don't put it in again. 3 over 2, 3 halves, is a new one. And 6 over 2 is 3. I already had that here, so I'm not going to add that. Then I'd go to my last denominator. 1 over 4 would be a new. 2 over 4 is a half. I already had that here, so I'm not going to add that to the list. 3 over 4 would be new. 6 over 4 is 3 over 2. I had that one here. So it would be positive or negative, one of those. So that's 1, 2, 3, 4, 5, 6, 7, 8. And with a positive or negative, that's 16 numbers that we could try as the possible rational zeros here. If we could identify one of those or two of those, we could factor x minus that root out and get that thing down in its order, and then maybe get it down to a point where we could factor it. Now to see how that process works, I've written up a second example. And I say, for the polynomial 2x cubed minus 5x squared plus 6x minus 2. Now that's a little bit too complicated for us. It doesn't factor by grouping, and it's got 4 terms. So in its current form, it's too complicated for us to break down. But if we knew a rational root, say a number c that was a rational root, I could divide that by x minus c. that would reduce the order to 2, and then if nothing else worked, I could always use the quadratic formula to finish finding my zeros. So let's go ahead and see how this works. The first thing it says is list all possible rational roots. Okay, so I want to list x is equal to positive or negative, and for my numerator I want all the factors of the last coefficient. Well, the last coefficient's 2, so its only factors are 1 and 2. And I want to put that over all the factors of the first coefficient. Well, the first coefficient's also 2, so that would be either 1 or 2. So using the 1 on the bottom, I get positive or negative 1 over 1, which is 1, or 2 over 1, which is 2. And then using the 2 on the bottom, I get positive or negative 1 over 2, which is a half, and then 2 over 2, which is 1, which I've already stuck in my list here. So I have 6 possible zeros for that function. So if I had the polynomial equation 2x cubed minus 5x squared, I would have 6 possible solutions to the polynomial equation. Okay, the next part says use synthetic division to check for zeros. Now, if any of these numbers are really zeros, then I'll take x minus that number, divide it into here, because if 1 is a 0, then x minus 1 is a factor. So I'd divide x minus 1 in here. That would reduce this to second degree, and if nothing else works, I could at least use the quadratic formula to get my other 2 zeros. Now, these zeros could be real numbers, they could be imaginary numbers, we don't know. But the ones that we're looking for first are rational zeros, so those are going to be real numbers. Well, if I go to my first possible zero, that's positive 1, I don't really need synthetic division to check positive 1. I could just plug that in and see if I get a 0. So if I plugged a 1 here, I'd get 2, minus 5 would be negative 3, plus 6 would be positive 3, minus 2 would be 1. So I didn't get a 0, I got a 1, so 1, positive 1, is not a possible solution. So for positive 1, So I try negative 1. Negative 1 cubed is negative 1, so 2 times that is negative 2. Minus 5 is negative 7. Minus 6 is negative 13. Minus 2 is negative 15, so negative 1 didn't work either. Well, the 2 is a little bit harder. So to check out the 2, I'm going to go ahead and do what it says and use synthetic division. So down here I've got my, if 2 is a root, then x minus 2 will be a factor. To divide my polynomial f of x by x minus 2, I first want to change the sign to positive 2. Then I want to write all my coefficients of my polynomial here and start my synthetic division. I bring down the first number 2 right here. Then to finish it off, I multiply here, put it here, and add. Multiply here, negative 2, put it here and add. Multiply here, 8, and add. I get 6. That's not 0, so it did not evenly divide, so 2 is not a possible root. So let's try negative 2. Bring down my first coefficient again. Multiply, negative 4, and add. Multiply, positive 18, and add. Multiply, negative, oh, this isn't even coming close. Instead of getting a 0 remainder, I get a negative 50 remainder. No way. So, I've tried positive 1 and negative 1. I've tried positive 2 and negative 2. The only 2 hopes that I still have, and these don't have to be roots, but they're at least hopes, would be positive a half and negative a half. So here I'm going to try positive a half. I bring down my first number. I multiply, a half times 2 is 1, and I add. I multiply, a half times negative 4 is negative 2, and I add. A half times 4 is 2, and I add, and that's 0. That means x minus a half divided that evenly. So that means our original function up here, f of x, can be written as f of x is equal to x minus a half, that's what worked out as a factor, times, and now the rest of it comes from this, 2x squared minus 4x minus 4. Now, the next thing you'd want to do is you'd want to see if this factors. You can go ahead and play with that for a minute, but I got to tell you that doesn't factor. So what I'm going to do is I'm going to get my other two roots using the quadratic formula. So I'll say x is equal to negative b. Now b here is negative 4, so that's negative negative 4. Plus or minus the square root of. B squared is going to be negative 4 squared, which is 16, minus 4ac. Well, a is the number positive 2. C is the number negative. No, it's not either. It's the number positive 4. I miscopied. It was 2, negative 4, 4. So this is supposed to be a positive 4 here. So this is a positive 4. And this is all over 2a, 2 times 2. So this is going to be 4 plus or minus, that's 16 minus 32. So that's negative 16 all over 4, which is going to be 4 plus or minus 4i over 4, which is going to be 1 plus or minus I. So my three zeros of the polynomial, or my three solutions of the polynomial equals 0 are x equals a half, x equals 1 plus I, and x equals 1 minus I. Notice it was degree 3, and I got 3 solutions, and that completes the podcast on rational zeros. Now, in our next podcast, we'll look at an application of this. How do you use this to solve practical problems? And that completes the podcast.